Hello, this is Dr. Lori. Welcome to this discussion on the ChiSquare distribution. As a quick reminder, you've seen the Z distribution, and it has a mean of 0, which means that half of the distribution is below 0 and half of the distribution is above 0. Its shape is symmetrical. So in other words, it's just as much below 0 as it is above 0. And the value of the Z statistic above and below 0 is correlated with a p-value that tells you the probability of obtaining a Z statistic that extreme or more extreme. So in other words, if we have a Z statistic of 2, the p-value tells us how much would be beyond 2. When we're dealing with a categorical outcome, in other words, it could be dichotomous or nominal or ordinal, we need to have a different distribution because the Z distribution works along a continuous scale. And so what we use instead of a Z distribution or a T distribution is that we use something called a chi-square distribution, and the picture of what that looks like is an X, a fancy X squared. So that letter is called chi, and so that's the chi-square distribution. And it has some different features as compared with the Z distribution. First of all, it starts at 0. And so it is not symmetrical, it's asymmetrical. The whole entire distribution is above 0. So there's nothing to the left of 0, it's all to the right. And the shape of the chi-square distribution depends on what's called the degrees of freedom. So with 1 degree of freedom, if you remember, if we have a 2 by 2 table, basically we end up with 1 degree of freedom, because as soon as, if we know our row totals and our column totals, as soon as we fill in 1 square, then the rest of those 3 squares can be calculated, and so they are no longer up for grabs. And so with a 2 by 2 table, we have 1 degree of freedom, and this is what the shape of the chi-square distribution approximately looks like. The mean is equal to the degrees of freedom. So if this is 1 degree of freedom, then half of the distribution will be below 1 and the other half will be above 1. Now what we're really after is we're looking for where the cutoff would be if we have 95% of the area, and that actually happens at a location of 3.84. Now, I don't expect you to memorize a whole lot of values, but you should have kind of a sense of how big or small a particular Z statistic or chi-square statistic is. So at 3.84, that's the same location that the p-value is equal to 0.05. So it's similar to 1.96 for a Z distribution. That's where the p-value equal to 0.05. And so what that means is that if you have a chi-square value of 3.84, the chances of getting that value or greater, remember, goes out into the tail. This looks like it swoops up, but it actually continues to go down and down and down. The probability of getting a value that extreme or more extreme is 5% if the null hypothesis were true. So basically what that's telling us is the area under the curve out here is 5% of the total area under the curve at chi-square is equal to 3.84. So those are some basic features to know about the chi-square distribution. Really, it's used to help us understand about the probability of random error or chance happening and finding an association based on chance alone. So hopefully that puts this chi-square distribution in perspective and helps you understand a few of the features about it. If you want to know more, I'm sure you can find that on the internet or in a textbook, but I hope this is helpful for you as you're understanding chi-square.